All right, guys, so today we're going to talk about solving quadratics. So, getting into this unit where we are actually getting number answers, like such as x equals 5 and x equals 2. So, we have 5 different ways that we can solve quadratics. Today, we're going to talk about 2 of them. So, the first way, graphing, is pretty simple, and then the second way is by factoring, and we're going to be practicing that for the rest of the week. Um, even though we've already done it, you guys know how to do it, but we're just going to do some extra practice on that. All right, so solving quadratics by graphing. All right, so a couple things to go over first. Quadratic roots. So this is what we call answers to a quadratic. And so quadratic roots are the points at which the parabola. So remember, parabola is the graph of a quadratic, intersects the x-axis. All right, and so since I'm writing it down here, you guys should be following along with your own notes and making sure that you're putting this down on your notes as well. So quadratic roots is the points at which the parabola intersects the x-axis. So when we say that we're going to solve a quadratic, we're finding the quadratic root, meaning we're finding where does it cross the x-axis. All right, other names, other synonyms for quadratic roots, this is the solution or the answer to a quadratic problem. We can also say we're finding the zeros. We can also just say solutions, or we can call them x-intercepts. All right, these are all synonyms, meaning they all mean the same thing. So we have roots, zeros, solutions, or x-intercepts. We call them, all of those words are interchangeable. All right, so the quadratic equation, ax squared plus bx plus c, this is standard form. We've seen that a lot. But now instead of it being y equals, we're making this equal 0. So in order to solve a quadratic equation, it must always equal 0. It must always equal 0. That's the only way that we are able to solve a quadratic. So essentially, with graphing, the answer to a quadratic equation is finding what x equals when y is 0. So when we're solving the quadratic equations, we want to know what is x when y is 0. That's what it means to solve a quadratic equation. So on a graph, speaking specifically about graphing, on a graph, this is found at the x-intercepts. So we have 3 different types of solutions. All right, we have where you have 2 solutions, 1 solution, or no real solutions. All right, let's talk about each one of these. So with 2 solutions, this is where it's crossing the x-axis and it's crossing twice. So that means we have 2 solutions. So if we look here, we look like we're crossing at -1 and 3. So we would say x equals -1 and x equals 3. All right. Something else to remember, when you have a quadratic, right, if we're writing in standard form, we have this squared. So the fundamental theorem of algebra, which is a big long thing telling us that whatever the highest exponent is, that's how many solutions we should have. So we should have 2 answers to a quadratic. All right. Now, if I look at the second one here, where it says 1 solution, well, that kind of contradicts everything I just said. However, we've talked about this before. So for this one, notice that our vertex just touches the x-axis, doesn't cross all the way through it. All right, and so this is at x equals -1. This is what we call a double root, right? We've talked about this, meaning it's the same answer twice. Okay, so if the parabola just touches, the vertex just touches the x-axis, and that's called a double root, and we have 2 of the same answers. All right, and then finally we have where there's no real solution. So here's my x-axis. I know it's kind of hard to see on this, but notice that my parabola is above it, and I don't actually ever cross it. So we say no real solutions. Notice this word real. That's become real important. Okay, so there are no real solutions. And you can say this with graphs, all right? But I'm going to put a big star here because you can only say this with graphs. If you see a graph like this, then you can say no real solutions. Now, if we're solving an actual equation with all the numbers and it looks like in the, like standard form or whatever it may be, then we can't say that. We have another way of solving that. So in a couple weeks, we're going to be getting into what's called the imaginary number system. And so we're going to look at, there's a whole nother number system that we're going to look at where we can find the answer to this quadratic. But for now, and with graphing, we can say this is no real solutions because there's actually an imaginary one. So this is only for graphing can we say this. If we're solving it algebraically, we will be able to, I'm going to give you those tools to be able to solve equations that would graph and look like this. Okay, so we'll get into that in a couple weeks. But for now, if on a graph the parabola does not cross the x-axis, then we say there's no real solutions. All right, so down here, there are 3 examples. I went ahead and graphed these for you. So if we take a look at this first one, okay, it crosses twice. The second one crosses once, and then clearly this one doesn't cross at all. All right, so we can go ahead and say no real solution. Okay, now for the other 2, quickly pause the video or just take a second and go ahead and write down what your x values would be or what your solutions, what your zeros, what your roots, what would those be for these 2 graphs. So if you need to, go ahead and pause the video and do that. All right, hopefully you have answers for these. So if I look at this first one, it crosses at 2 and 6. And then here, this is our double root. It's crossing at 1. So I say x equals 1 and x equals 1. Notice that I write it twice. For now, I want you guys to write this twice because I want you to recognize that a quadratic has a squared, which means we have 2 solutions. And so this is showing the 2 solutions. Okay, now on the no real solutions, again, when we do imaginary number system, you actually will find that we have 2 solutions. All right, so again, for the double root, I want you to go ahead and write it out twice, okay? All right, so that's solving quadratics by graphing. We are not going to do a ton of this. Basically, I want you to be able to see it on the graph. Like, we're not going to do a ton of graphing with this. Think back to when we did word problems with quadratics, the rockets taking off, and then where it hit the ground was how long the rocket was in the air. You were actually solving the quadratic equation, all right, by graphing. Okay, so we'll get back to those at the end of the unit as well. All right, so that is solving quadratics by graphing. It's where the parabola crosses the x-axis. You can have 2 solutions, 1 solution, or no real solutions. Okay? All right, go ahead and flip it over. So this is getting us back into factoring again. So I know we've done this a couple of times, but I feel like we're still a little rusty on it. So I want to make sure that we practice this to the point where you guys can do these in your sleep. All right, so again, quadratic roots, we're going to reiterate this again. So quadratic roots, which is the solution or the answer to a quadratic equation, is the points at which the parabola intersects the x-axis. And we're going to write this every time we take notes or we learn a different way of solving a quadratic. We're going to be doing this part again, just to reiterate what the definition is, and also that we can call these zeros, solutions, and x-intercepts. All of these words are interchangeable. So roots, zeros, solutions, x-intercepts. Okay, solving quadratics by factoring. We already know how to factor, right? So we have the main part of this down. Now we're just going to add an extra step at the very end. So we can look at this. So unfortunately, this method does not work for every single quadratic equation. All right, this only works for the ones that are factorable. So sometimes we're going to find that this method doesn't always work, okay? but it is probably the method that you're going to end up preferring because you guys know how to do this and we've done it so often. All right, so step one, set the quadratic equation equal to 0. That is super duper important. Okay, so just in case, sometimes they're not equal to 0, so you need to make sure it equals 0. Step two, factor the left side. So in the example, it doesn't really matter if your equation's on the right side or left side, wherever your zeros is fine. And then set each factor equal to 0 and solve each factor for x. I'll show you what that means. And then you write your answer as x equals and x equals. All right, that second step where it says factor, this, we're doing the AC method. All right, so we're using the AC method in order to factor this. Okay, so let's look at this first example. All right, so we're given y equals x squared plus 3x minus 10. So first thing I need to make this equal to 0. So I'm going to have this as x squared plus 3x minus 10 equals 0. So I'm setting it to equal 0. So then we're doing our AC method. We're taking a, right? Remember that there's really a 1 here, right? So a times c gives me negative 10. My middle term is a positive 3. I'm going to write out the factors of 10. Okay, this is where you can use your yellow factoring sheet if you would like to. So as I look at this, I need to multiply and get a negative and add and get a positive. So because I have to multiply and get a negative, I know my two signs. One's going to be positive, one's going to be negative. Then I look at this one. This is positive. So that must mean the bigger of the two factors has to be positive. So whatever sign this B term is, that's the sign of your bigger factor. All right, so the sign on the B value is the sign on the bigger factor. Okay, all right, so I'm going to use 2 and 5. So this is going to be a positive. It's going to be a negative 2 and a positive 5. Again, my bigger one has to be positive because my B value is positive. So now what I'm going to do is I am going to take this plus 3x out and I'm going to put in these two terms, putting x with each of them. So it's going to look like this. So I have x squared minus 2x plus 5x minus 10 equals 0. So first term came straight down. I replaced 3x with my two factors, and then I brought down my negative 10 and brought down my 0. All right, so from here, you either can do your factor by grouping or box method. So this first one I'm going to do by grouping. So I group these two together, I group these two together. The first two terms, I have an x in common. So that leaves me with x minus 2. I bring down my plus sign. Between 5x and 10, I can factor out a 5. So that leaves me with x minus 2. All right, so you should have where your two sets of parentheses are the exact same. All right, so that's one of our answers. So x minus 2. And then the leftovers, x plus 5. Now, this is where we normally would stop because we factored it. However, we now need to go an extra step. So if we go back over here, we completed 2, now we're on 3. Set each factor equal to 0 and solve each factor for x. So remember, this equals 0, this equals 0. So what we do is we're going to take this factor, x minus 2, and we make it equal 0. I take the second factor and I make it equal 0, and I solve each of these. So I would add 2 to both sides, and I would get x equals 2. Subtract 5 from both sides, and I get x equals negative 5. So my two solutions are x equals 2 and x equals negative 5. All right? So before, we would stop at this point here. Now we have a couple added steps that we have to do. All right, let's do another one. All right, so if we look at this first one, so it's already equal to 0, so we're good. Step 1 is done. So then we're going to do a times c. So I get 3, positive 3, and my middle number is a positive 4. The only factors of 3 are 1 and 4, so we know this is positive 1 and positive 3. So I'm going to rewrite this, taking the plus 4x out and putting in 1x, or just x, plus 3x. And then I bring down my 3 and then put my 0. All right, I'm going to do this one by box. So these 4 terms go inside the box. And I am looking for what they have in common. Looking at the first column, they have an x in common. X and 3, they have nothing in common, so I bring out a 1. X squared and x, they have an x in common. And 3x and 3, they have a 3 in common. So I have x plus 1, x plus 3 equals 0. Now I'm going to take each one of these and I'm going to set them to equal 0. Okay, so think of it this way. We're making the y value equal 0. Think about on a graph where it crosses the x-axis, our y value is always 0. So that's why we make these set equal to 0. So subtract 1 from both sides and I get x equals negative 1. Subtract 3 from both sides and I get x equals negative 3. And here are my two solutions. Box them up. All right. Okay, let's look at number 3. So on number 3, if I'm looking at this 2x, 10x, and 8, I have 2, 10, and 8. What can divide evenly into all of those numbers? Yep, 2. So you do have to make sure, so I'm going to make a note of it here, factor out the GCF first. And what this does is it gives you smaller numbers. So we don't have to deal with bigger numbers. We like the smaller numbers. You have less factors, which means less choices to have to pick through. All right. So I'm going to factor out a 2. So that leaves me with x squared plus 5x plus 4 equals 0. Now, this 2 on the outside, I'm going to do absolutely positively nothing with. Okay, I'm doing nothing with it. I'm going to leave it on the outside and it will just stay on the outside the whole entire time. So now I'm going to do my a times c, gives me 4. I have 5 in the middle. So this is 1 times 4. So x squared plus x plus 4x plus 4. I'm going to group this one. So they have an x in common, so I have x plus 1. 4x plus 4, they have a 4 in common. My parentheses match, so x plus 1. Leftovers, I have x plus 4. All right, now, normally we would then say, okay, you just bring down the 2 and we're done. But we're not. So we have to remember that this still equals 0. So I'm going to take x plus 1 and make it equal 0. X plus 4, and that equals 0. Solve this one, and I get x equals negative 1. And then minus 4, and I get x equals negative 4. Notice that this 2 in the front does nothing to affect my solutions at all. All right, so by taking it out, we're just setting ourselves up with smaller numbers to work with. So my solutions are x equals negative 1 and x equals negative 4. All right. Okay, so let's look at a different one. So all of these so far, our a value has been 1. Let's look and see what happens when our a value is not 1. Okay. All right, so let's look at number 5. So I first look 2, 3, and 5. There's nothing that divides evenly into all of those. So I'm going to go straight to a times c. All right, so we have 2 times negative 5 is negative 10, and we have to equal 3. So 1 times 10 and 2 times 5. All right, so I have to multiply and get a negative. So that must mean my two signs are going to have to be different. So one of my factors is negative, one is positive. So then I look at my b value. My b value is a positive 3. So that means the bigger of the two is going to be positive. So this is going to be negative 2 times a positive 5. All right, so I'm going to rewrite this, 2x squared. So I bring down the first one. I'm going to take 3x out, and I'm going to replace it with this negative 2 and 5. So minus 2x plus 5, and then I bring down my last term, minus 5. And all of that equals 0. All right, we're going to throw this in a box. So 2x squared, negative 2x, 5x, and negative 5. All right, so if I look down the first column, they both have an x in common. Now, because this first term is negative, I know a negative's coming out. They have nothing in common, so I bring a 1. Going diagonally. Now, they both have a 2x. And then 5x and 5, they both have a 5. All right, so now I have x minus 1 times 2x plus 5 equals 0. I set each one of these to equal 0, and I solve. So I get x equals positive 1. Here, subtract 5. So those cancel. I have 2x equals negative 5, and then I divide by 2, and I get x equals. Now, we get a fraction. Now, with anything to do with quadratics, we are going to leave this as an improper fraction in lowest terms. Okay, so if for some reason, if this was negative 10 over 4, you would simplify that to negative 5 over 2, but we're not changing that to 2.5. All right, so we're leaving this as negative 5 over 2 and x equals 1, and those are your two solutions. So when your a value is bigger than 1, typically you'll end up with a fraction answer or two fraction answers. All right, so let's look at another one. Look at number 8. Actually, let's flip over. Go ahead and flip on over. Let's look at, let's look at number 6. Okay, so on the back side or the next page, let's look at number 6. So if I look at my terms, I have 6, 5, and 1. So I am going to do A times C. That gives me 6. And then my middle term's 5. So I have 1 and 6, 2 and 3. Now, this is one of the most missed problems, right, is when we're dealing with 6. Because we have two options here. Now, I could do negative 1 plus 6, and that gives me 5. Or I could do 2 plus 3, and that gives me 5. Here's the difference. If I do this, if I multiply it, that gives me a negative 6. Notice here, this is positive. So that does not work. If I do a positive 2 times a positive 3, that gives me a positive 6. And then if I add those, that gives me a positive 5. So 2 and 3 are my two numbers I'm going to use. So again, I'm going to take out the 5x and replace it with these two numbers here. So I have 6x squared plus 2x plus 3x plus 1 equals 0. All right, I'm going to do grouping this time. So if I look at the first two, I have 6 and 2. I can divide those both by 2, and then they both have an x. So this leaves me with 3x plus 1. And then my second one is 3x plus 1, so they have nothing in common, so I bring out a 1. 3x plus 1. My parentheses match, so 3x plus 1 times 2x plus 1. Those are my leftovers. Again, this equals 0. Then I take each individual one and I make it equal 0. And I solve from here. So subtract 1 from both sides. I get 3x equals negative 1. Divide by 3. So I get x equals negative 1/3. So there's one answer. Over here, I'm going to subtract 1 from both sides. 2x equals negative 1. Divide by 2. And I get x equals negative 1/2. Okay, so notice on that one, my a value was bigger than 1, and both of my answers ended up being fractions. Okay, and that can happen. All right, a few more to look at really quickly. So take a look at number 9. Remember, our first step is to make sure that it equals 0, and in this case, this does not equal 0. So what am I going to do with this negative 2 here so that I can move it over to the left-hand side so that this would be 0? Exactly, we're going to add it. So you're going to add 2 to both sides. Now, this has an x, my 2 does not. This has an x squared, my 2 does not. So can I combine any like terms? No, I can't. So this just becomes 3x squared plus 7x plus 2 equals 0. Now my equation equals 0. Now I can solve it. All right, and so from here you would do a times c and go on from there. All right, look at number 10. All right, on number 10, we have 8x squared plus 3 equals 10x. All right, so we need to move this over here on this side so that it's 0. So to do that, I'm going to subtract 10x from both sides. Now, this first term has x squared, so those aren't like terms, and the 3 doesn't have an x at all. So none of these are like terms, so we can't combine anything, but I am going to write it in the correct order, our standard form order. So this is 8x squared minus 10x plus 3 equals 0. All right, be careful. Try not to write this out of order, because if you were to write this out of order, it would look like this and your AC method would not work. Okay, so it has to be in standard form in order for your AC method to work, so don't write it like that. Finally, if you look at 12, notice that you have stuff on both sides, and now we have like terms. So I would subtract 4x. So on the left side, I'm going to find the term that has just an x, and I'm going to put it underneath there. So those cancel. So I have x squared. Negative 10 minus 4 is going to give me negative 14x. Plus 49 equals 1. And now I need to move the 1. So I'm going to subtract 1. I put it under the like term. Plus 48 equals 0. And then from here, you would do your a times c. Okay? Please understand what I just did on number 12 and what we did on 9 and 10. Those aren't done. You would then need to factor it and keep going and getting x equals something and x equals something. All right? I was just showing you how to set them up. All right, what I would like for you to do, I would like for you to go through and work on the problems that we have not done. So on the front side, there's 1, 2, 3, 4, 5 total. So you can work on those. So on the front, actually, let's do this. Okay, I'm going to tell you what problems I want you to do. So I would like for you to complete the following problems. I want you to do number 2. I want you to do number 4. And I want you to do number 8. So 2, 4, and 8 are the problems on the front. All right. And then if you flip over to the next page where it starts at the top with 5. So this is the front side of the second page of the packet. So I would like for you to complete number 5. I would like you to complete number 7, number 10, and number 11. So on this one, we got 5, 7, 10, and 11. And then finally, on the very back side, so on the very back side, there are 8 problems. I would like for you to do problem number 2, problem number 3, problem number 6, and problem number 7. All right, so let's recap this one more time. So what is expected of you when I come back and I see you guys on the next day in class? You need to have the following problems completed. So if we go back to the very, very front with the graphs, there's nothing to complete on that page. Go to the back side of the first page. You need to complete 2, 4, and 8. You might want to write this down or go ahead and highlight it on your paper. If we look at the front of the second page, I need for you to do 5, 7, 10, and 11. 5, 7, 10, and 11. I've already started number 10 for you, so you just need to work from there. And then on the very, very back side, you are doing 2, 3, 6, 7. All right, so make sure those are completed before you come into class tomorrow morning. Okay, if you have any questions, you can send me a message on Schoology, talk to the person sitting next to you, whatever you need to do. All right, okay, if you have questions, let me know, guys. Thanks.